students, in this video we see the topic electrochemistry session 5. Already saw the 4 sessions. Okay, now 5th session. Before watching this video, you subscribe the channel and press the bell button. Okay, thank you. Now the learning objective in this session is what is electrochemical cell. Example for electrochemical cell: galvanic cell, oxidation half cell, reduction half cell, joining the half cells, anodic oxidation, cathodic oxidation, salt bridge, completion of circuit, consumption of electrodes. Next, galvanic cell notation, EMF of the cell. These are the topic. We will see that in this session. Okay, now one by one we will see that. What is electrochemical cell? What is electrochemical cell? The electrochemical cell is a device which converts chemical energy into electrical energy and vice versa, reverse also. Chemical energy into electrical energy, electrical energy to chemical energy. Also, both are in this cell. Okay, that's why electrochemical cell. Next, it consists of two separate electrodes which are in contact with an electrolyte solution. In this cell, two electrodes, positive electrodes and second negative electrodes, they are contacted through electrolytic solution. Okay. Electrochemical cells are mainly classified into the two types. Mainly classification number one is galvanic cell, voltaic cell. The example for galvanic cell or voltaic, another name is voltaic cell. Second one is electrolytic cell. What are they? What are the difference between them? We will see that. Okay. Now galvanic cell. Another name of galvanic cell is voltaic cell. In this device, the spontaneous chemical reaction generates in an electric current. It converts chemical energy into electrical energy. It is commonly known as battery. You know very well. We have used a lot of so many types of battery in our human life. Okay, these are the electrical energy produced from the chemical reaction. So it converts chemical energy into electrical energy. Okay, this is the main principle for this device as a battery working. For example, this galvanic cell, this is the diagram for that. Galvanic cell have zinc sulfate and copper sulfate solutions are separated in beaker. Zinc sulfate and copper sulfate. The electrodes are there. Zinc electrode 1, another one is copper electrode. Zinc electrode is acting positive electrode and negative electrode, and another one is positive electrode. Anode is negative, cathode is positive. Okay, oxidation, carry on oxidation, it occurs in reduction. So through this the two solutions are connected with salt bridge. In salt bridge, the zinc sulfate solution, the solutions are passed from the ions one beaker to another beaker through salt bridge. Okay, now this is the basic principle for galvanic cell. Next, electrolytic cell. The electrolytic cell means it converts electrical energy to chemical energy. Electrical energy, we pass the electrical energy and it is converted to chemical energy. This is the non-spontaneous reaction. Non-spontaneous reaction means if current is there, it will work. Electrolytic cell, this is called. Electric current from external source passed through the solution, it converts electric energy to chemical energy. This is the principle for electrical cell. For example, for this, see the image, one solution taken in the beaker and two electrodes, anode and cathode, through external battery connected with external battery. In beaker, the electrolytic solution is there. Electrolytic solutions have positive ion and negative ion, that is anion and cations are there. If current is passed through this, the anion is passed through negative electrode, negative ion passed through positive electrode, towards positive electrode. This is the principle for this electrolytic. Mainly the electrochemical energy is chemical energy to electrical energy. In electrolytic cell, electrical energy into chemical energy. This is the principle for these two types of electrical cells. Now, what are the difference between galvanic cell and electrolytic cell? The two images are there, galvanic cell and electrolytic cell. Okay. Now, changes chemical energy into electrical energy, changes electrical energy into chemical energy. Already see the definition, saw the definition before that. In this galvanic cell, the two solutions are connected with salt bridge. Anode is acting as a negative and cathode is acting as a positive. That is oxidation and reduction. Okay. Here external battery, one solution is there, the electrolyte, the two electrodes are immersed in this solution and one external battery is connected. From this battery, the current is passed through the electrodes. The positive ion, positive electrode and negative electrode, positive electrode absorb, that is attract negative ion, and negative electrode attract positive ion. So this is the basic principle. Okay, first in galvanic cell, anode is negative, cathode is positive. The spontaneous reaction occurs, does not require external voltage source. This is the points we have. Next, in this electrolytic cell, electrical energy into chemical reaction, anode is positive, cathode is negative, non-spontaneous reaction. Only the manually if the external source is connected, so non-spontaneous reaction, require external voltage source, required external voltage source. Next, we see the detailed study, galvanic cell. Galvanic cell is also known as voltaic cell. Now, chemical energy is converted to electrical energy. Anode is negative and cathode is positive. Anode means positive electrode and cathode means negative electrode. It is negative and positive. Oxidation takes place at anode. In here, the zinc sulfate and copper sulfate solutions are kept in two beakers. The electrodes are immersed in each one, and then salt bridge is there through the tube. Sodium chloride salt bridge, common solution NaCl. Okay. Now, discharge, oxidation takes place in anode. Anode is a positive electrode. Here oxidation is occur, and then negative electrode, in electric electrode reduction is occurs. This is the spontaneous reaction, flow of electrons from anode to cathode, The zinc ion, in this zinc sulfate, the zinc ion release the electrons, These electrons move to the negative electrode, the copper sulfate solution, copper ion accept the electron and then changes to copper. This is the principle. Okay, electrons leave to the cell at anode and enter cell at cathode. Positive to cathode, the electrons are moved. Flow of electron generates current. From this, the flow of electron from positive to negative, the current is produced. This current is identified by the voltmeter. This is the basic working method. We have already learned 11th standard, when a zinc metal strip is placed in a copper sulfate solution. Zinc is immersed in copper sulfate solution. Zinc metal strip is placed in lower class. We will see that the blue color fades the copper deposited on the zinc strip, the brown crust due to the following spontaneous reaction. Already see that in lower section, lower classes, we see that in 10th standard also, the brown zinc strip is dipped in the copper sulfate solution. Copper sulfate solution means blue color solution dipped into the copper sulfate. The copper ions are deposited on the strip. It take the color change, red brown crust due to the following spontaneous reaction occurs. What are the reaction? Zinc metal plus copper sulfate solution gives zinc sulfate and copper. The copper sulfate, in copper sulfate, copper ion release the electron and zinc is release the electron and copper sulfate accept the electron. So oxidation and reduction simultaneously occurs. It take the zinc sulfate and copper deposited on this zinc strip. This is the basic principle. Next, the energy produced in the above reaction lost surroundings as heat. In this reaction, we can't use the heat because we observe the heat from this reaction. So due to the electrode changes electrode to positive electrode to negative electrode. This is the heat is due to this principle. Okay, the energy produced in the above reaction is lost and the surrounding as heat. Okay, next, the above redox, this is the redox reaction because one is oxidation and another is reduction. The redox reaction, zinc is oxidized to zinc 2 plus ion because zinc loses 2 electron, release the 2 electron, and copper 2 plus ion accepts that 2 electron to metallic copper. The half reactions are represented as below. Okay, I already told that zinc lost the 2 electron and it changes to zinc 2 plus ion, that is oxidation. Copper 2 plus ion in solution, copper sulfate solution, it takes the 2 electron to convert it to copper solid, that is reduction. Okay, if we perform the above half reactions separately in apparatus, the energy produced in the reaction will be converted to electrical energy. In this reaction, from this reaction, we already take the electrical energy produced by this chemical movement, that is electron movement from one electrode to another electrode. The chemical energy converted to electrical energy, that electrical energy we use the externally. Okay. Now the function of galvanic cell, considering Daniel cell is the example. Daniel cell is the example for this cell. The above reaction generation of electrical energy. The separation of reaction, basis of construction of Daniel cell, it consists of 2 off cells. Off cell means one off and another off. That is one oxidation off and another reduction off. This is the
concept. Okay, now 2 off means one bottle have the zinc sulfate, zinc and zinc sulfate. Another off is copper sulfate and copper. Okay, in this reaction, zinc is released the 2 electron and the electron moves to the another electrode. Another electrode have 2 copper 2 plus accept 2 electron changes to copper. Copper deposited in the electrode also already have the copper electrode that deposit. This is the reduction is oxidation is taking place. Zinc is converted to zinc sulfate. Okay, this is the working method. Next we see the part by part the example. Oxidation of cell. Oxidation of cell means already told that zinc is losses of 2 electron and changes to zinc 2 plus ion. Okay, reduction of cell. Reduction of cell means copper strip dips into the aqueous solution of copper sulfate taken in the beaker of cell. Okay, one is zinc strip and another one is copper strip. Joining the two cells, one salt bridge is there. The salt bridge, the zinc and copper strips are externally collected using wire through the switch and load. Load means voltmeter for measurement of the flow of current. Okay, this is the joining the two half cells. The electrolytic solution present the cathodic and anodic compartments are connected using inverted U-tube. Inverted U-tube means that is the salt bridge of the cell. In this U-tube, that is see the picture, one U-tube is invertedly fixed with two beakers. Inside the U-tube, the agar-agar gel is mixed with an inert electrolytes, potassium chloride and sodium sulfate. Potassium chloride or sodium sulfate, any one is kept with agar-agar gel. Agar-agar gel is mixed because this is a medium for this. The ions of inert electrolyte do not react with other ions present in the half cells. They are not either oxidized or reduced at the electrodes. Inert electrolyte, this is the inert electrolyte, KCl and potassium sulfate example, because they do not either oxidized or reduced in these electrodes. Okay, this is a common for these two beakers. They joined with salt bridge. Okay, next the solution of the salt bridge cannot get poured out, but through which the ions can move into or out of the half cells, because the salt bridge have agar-agar gel and common electrolyte like potassium chloride and sodium sulfate. So any one in this the purpose of this salt bridge is to move the ions from one electrode to another electrode, inside or outside. Okay, this is the usage for salt bridge. When the switch closes the circuit, the electrons flow from zinc to copper strip, because zinc is lost the 2 electron and copper 2 plus ion accept the 2 electron. Okay, this is the principle. See the equation. The following redox reactions. Anodic oxidation, I already told that zinc strip is losses the 2 electron. Zinc is losses the 2 electron. The 2 electron zinc ions are enter the solution. The electrons either zinc metal, then flow through the external wire, then enter to the copper strip. Electrons are liberated at a zinc electrode, hence it is negative, because negative anode act as a negative in galvanic cell. Already difference is saw the difference. Okay, this is the reason. For single loss of 2 electron, and 2 electron accepts in copper, so other of solution, the anionic oxidation, loss of electron, oxidation. Okay. Next, cathodic reduction. Cathodic reduction means I already told that copper 2 plus ion in copper sulfate solution accept that 2 electron from zinc metal, it changes to copper. The copper is deposited and the electrode immersed in the beaker, copper electrode. So deposited and that speaker, same deposited in the same electrode, then the electrons are consumed and it is positive. Gain of electron is reduction. Okay. This is the basic principle. You see the diagram. One beaker have zinc sulfate solution. Zinc sulfate solution immersed with negative electrode, anode electrode. Next another beaker, copper sulfate solution. The rod copper immersed in, they joined with 1 voltmeter. The salt bridge is there. So inside the salt bridge, agar cell, the chemical agar is there, and then agar gel is there, and with potassium chloride or sodium salt, any one. So the ions in copper loses the electron, release the electron. This electron moves from this beaker to this beaker through salt bridge. So we see the it releases the electron and changes to zinc metal. Zinc 2 plus ion, it changes to zinc 2 plus ion. The zinc metal is releases 2 electron and changes to the zinc minus ion. Okay, this is the concept. Okay, next beaker, copper sulfate accept the electron from through the salt bridge and changes to copper. You add the copper metal ion in this, deposited this. Okay. Now in this cell, one is reduced, one electrode is lost, one electrode is it is lost the metal, then one in copper is it increasing the size, one reducing the size, and another zinc strip is reducing the size, and copper metal is increasing the size. This is the diagram for this. The zinc is reducing the size, and then copper is increasing the size. Okay, because copper zinc is losses 2 electron to change the zinc sulfate, and copper sulfate is accept the 2 electron and deposited on the copper. Okay, this is the principle for this cell. Next, salt bridge. The electrolyte present in the 2 off cells are connected using salt bridge. The anodic oxidation, zinc electrodes increase the concentration of zinc 2 plus ion solution. The solution contains more number of zinc. Yeah, already see that zinc 2 plus ion, zinc metal loses the 2 electron and changes to zinc 2 plus. They already dipped in zinc sulfate solution, so zinc 2 plus ion is increasing. Then compared to sulfate ion, the solution anodic compartment would positively charged. Similarly, the solution of cathodic compartment, the negatively charged 2 plus ion reduced in copper, the cathodic solution contain more number of sulfate ions compared to copper 2 plus. So one beaker is zinc 2 plus ion is increasing quantity, another beaker sulfate ion is increasing. So to maintain the neutrality the compartments, the reactive anions Cl minus and move the salt bridge to enter the anodic compartment. Same time K plus ions from the salt bridge to cathodic compartment. For this impact for one is higher concentration of ion zinc 2 plus ion, one beaker is sulfate ion. The balancing this equation, the salt bridge, from the salt bridge the chloride ion move from one electrode to another electrode. So this is the use of salt bridge. You understand it? This is the salt bridge of U-tube, inverted part of the cell. Okay, this is a full cell, and then next, completion of circuit. Completion of circuit, when the circuit is completed, the electron flow from negatively charged zinc electrode into positively charged copper cathode through external wire. The same time anion move towards anode and cations are move towards cathode compartment. This completes the circuit. Already know that the anions are towards the negative electrode, the cathodic cation towards the anode that is positive electrode. These are the principle: positive to negative electrode, negative ion to positive electrode. It moving from one beaker to another beaker through salt bridge. The consumption of electrodes. In Daniell cell, the zinc electrode gradually decreases. I already told that the mass of the copper electrode increases. So the metallic zinc electrode converted to zinc 2 plus and copper 2 plus ion converted to metallic copper. This is the reason for reducing size of zinc and increasing size of copper. Unlike dialysis, that certain cases the reactant products cannot serve as electrodes, and in such case inert electrodes such as graphite and platinum is used that conducts external circuit. In certain cases the reactant or products cannot serve as electrodes. In such cases inert electrode means graphite or platinum used to conduct current external circuit. This means some reactions, some cells, the ions are cannot serve as electrodes. So we use the external electrodes like graphite or platinum are used to conduct the electrocircuit. Okay, thank you. This session we complete that. Next topic we will see the another video. So please before closing this video, you subscribe the channel and press the bell button. Thank you.
In galvanic cell notation means how to write the cell in the equation type. That is the cell notation. Okay, now we can represent the electrochemical cell reaction with a notation called cell notation. What is cell notation? 2 more question. Represent the electrochemical cell reaction with a notation called cell notation. If we want to write the cell combination in theoretically, we represent the cell notation. So this is called cell notation, is also known as cell diagram or line notation. This is the cell meaning for cell notation. Okay, now shortened way, it is the representation of shortened way of the chemical cell, electrochemical cell, shorthand way for the represent of a cell notation. Okay, the cell containing, already know that cell containing anode part and cathode part, first half and one half and second half, that is anode part and cathode part. They are separated by two bars. Example, this is the two bars, this is two bar. Example for the representation of two part, anode part and cathode part. Okay, next salt, this is represent also salt bridge, double line, that is salt bridge. Okay, represent salt bridge. Single bar or slash representing the individual solid and aqueous solutions, that is single line representation. Okay, each part, in each part, single line rotation in each part is represented by the phase boundary change in state, that is solid and aqueous. Here aqueous and solid, this is the separation for single slash. Okay, now you mentioned the each phases, like solid, liquid and gas. Whatever the equation represented, that you should write the solid, aqueous, solid, or like gas, anyone you mentioned it, that is the cell notation. Okay, once again I will explain to you. There are two part of cell notation. One is anode part and another one is cathode part. One oxidation of reaction, reduction of reaction. That is the two halves are separated by the double line. This is represent the salt bridge. Single slash represent the each phase boundary. Phase boundary means phase boundary means that is solid or aqueous, you represent that. Okay, this is a in this cell, that is a galvanic cell, anode part is Zn is separated by Zn2 plus and 2 electron. It gives the it releases the 2 electron from zinc metal. At cathode part, copper sulfate solution accept the 2 electron from zinc and changes to copper, that is cathode part. This is the cell notation representation. Okay, next the another way for representation, Zns, Zn2 plus aqueous, the single slash is phase boundary, and copper 2 plus slash is copper is the phase boundary. This is the anode part, this is the cathode part. Left side is the anode part and the right side is the cathode part. Okay, you remember that left side from your view, anode part, and then right cathode part. This is the representation for the notation. All the equations of cells are represented in this way only. Okay, E0 is equal to 1.1 volt in this SM of the cell, galvanic cell, 1.1 volt. Next example, the redox reaction, reduction and oxidation simultaneously occurs, that is why redox reaction. Chromium and copper 2 plus salt, that is chromium metal,
solid, copper 2 plus is the solution, copper sulfate I think. Next, chromium. The chromium releases the 3 electron. It gives 3 electron. Totally 3 into 2, 6 electron. 6 electron accepted by copper and changes to copper metal. Okay. Chromium is changes to 3 plus, or one ion is releases, one atom releases 3 minus, that is 3 electron. 3 into 2, 6 electron. 6 electron accepted by each one copper ion accepted, copper ion 2 plus ion, 2 electron take is, therefore 3 into 2, 6. The 6 electron is released by chromium, is accepted by copper. Okay, this is the equation. Half of reaction, reduction reaction and oxidation reduction separately. Anodic oxidation, chromium releases 6 electron. Cathodic reduction, oxidation and reduction is accept the copper 2 plus ion, 6 electron by 3 Cu atom changes to C. Therefore cell notation is anode part and cathode part each side centrally double slash. Okay, single slash means phase boundary, that is chromium solid and chromium 3 plus salt, chromium 3 plus salt, this chromium 3 plus salt, and then copper 2 plus ion and copper. This is the example for the representation. Next, EMF of a cell. EMF of a cell means electromotive force. What is electromotive force? When two half cells of Daniell cell are connected, a spontaneous redox reaction it takes place, which results in the flow of electron from anode to cathode. You know that already explained to you. Thus, in the galvanic cell, one half cell from one half cell, the electrons are moved through salt bridge, and another cell accept that electron. This is the movement of anode to cathode. In this time, the force that pushes the electrons away from the anode and pulls them towards cathode is called the electromotive force. This is the definition for EMF. The movement of electron from anode to cathode, anode pushes the electrons away, because the electron releases and then it pushes to next electrode, that is cathode. Cathode pull the electron from the anode, the opposite, just opposite. They do the opposite job, that is one is pushes the electron, another electrode is pulls the electron. Therefore this type of movement is called electromotive force or cell potential. The another name of the EMF is called cell potential. Okay, this is the definition, very very important 2 mark question. Next, the potential is represented by volt. Next, 1 volt difference in electrical potential. 1 volt difference electrical between anode and cathode. 1 joule energy is released for each coulomb of charge moves between them. 1 joule is equal to 1 coulomb into 1 volt. That is the formula. 1 joule, the energy is released. How many energy released? 1 joule released means 1 coulomb charge into 1 volt current. This is the definition. 1 joule of energy is released, each coulomb of charge moves between them. That is the formula, very very important formula. So the cell voltage depends on the nature of electrodes, the concentration of the electrolytes and the temperature the cell is operated. This is the cell basic principle. The voltage depends, the cell voltage depends on the nature of electrode. Nature of electrode means the electrode easily releases the electron or easily accept the electron. This is the nature of
the electrodes, and the concentration of electrolytes. Concentration of electrolytes means without electrolyte no movement are there in electron. So through electrolytes the movement of electron from one electrode to another electrode. So this is the 2 points. Remember that one is nature of electrode and another is the concentration of the electrolyte. Next, the EMF of Daniel cell is 1.1 volt. I already note that. See cell notation Zn S Zn 2 plus, this is the anode part, and double slash salt bridge copper 2 plus and copper. In this aqueous solution concentration, mention the aqueous solution concentration in bracket 1 mole 1 mole. Okay. Thank you for watching the video. Once again, next session session 6 we will explain the topic about measurement of electrode potential, thermodynamics of the cell reaction, and Nernst equation. Thank you.